statistics research facility of Ernst & Young, and he will tell us about the boomerang effect, or how to use session puzzling to attack your stuff from the backend. Have fun.
Okay, can you hear me? Great. So, hello everybody. My name is Shai. I'm a security researcher and analyst, and also the CTO of a group called Hactics, which is an advanced security center of Ernst & Young. Hactics used to be a privately held boutique company, but it was bought by Ernst & Young in 2011, and since then joined the worldwide group of security centers by Ernst & Young. I got you guys straight after lunch, so it's a challenge, but it's a challenge I'm looking forward to, since I couldn't have hoped to get a better subject, at least as far as I'm concerned. I'm here to introduce a couple of interesting subjects, but they all revolve around one main subject, which is an underemphasized attack vector called session puzzling that can enable attackers to attack the application externally from a trusted resource, a resource that is rarely validated, resources such as the session memory, the database content, the other server-side trusted repositories. And since these repositories are relatively trusted by developers, they are rarely validated like direct input, which makes this attack vector a fantastic method to bypass security mechanisms. And in many, many cases, even abuse security mechanisms for the purposes of the attack. So I can go on and on about the mechanics, but instead of explaining how it works, I think I'm just going to give you a short demonstration about a very basic scenario of session puzzling, just to get a glimpse of what we're going to talk about during the presentation. So we have a demo application called PuzzleMall, which is generally a puzzle e-commerce application. I'm going to log in. We're using a low-privileged user, user 1, password guess me. Now, there's an internal page in the application. It's called View Profile. I'll just copy it here, so you'll be able to see the URL. That's the URL, the View Profile URL. I'm going to log out and attempt a simple forced browsing attack. Okay? I'm going to try and access this page directly without logging in, just to get a glimpse of how this application works like. So accessing that internal page, View Profile directly, I'll do it again, didn't do anything at all, because the application has an authentication verification mechanism that verifies whether or not the user actually has authentication information in his session memory. Because I logged out and didn't really log in again and accessed an internal page directly, there was nothing in my session memory that proves my identity. So the application kicked me out, okay? However, using a scenario such as session puzzling, all I have to do is the following seemingly confusing process. I'm simply going to go to another process in the application, any process that deals with a user identity. In my case, a password recovery mechanism. I'm going to initiate the password recovery mechanism with a valid user. That's all. Just initiate the password recovery mechanism with a valid user account. In this case, an easy-to-guess user account, the admin account. As long as I initiate the process, since it's a multi-phase process, the previously entered username has to be stored somewhere, so the next phases will be able to access it. Just after starting that process simultaneously, I'm going to try accessing the internal URL again. And I want you to take a look at what just happened. A seemingly bizarre scenario in which initially I wasn't able to access the internal URL directly. All I did was to activate another process in the application that happened to deal around with the username parameter. And then I tried again to access the internal URL, and finally I got an access to an admin account. Now, the testers among you, which has some pen testing background or are familiar with that attack, will probably already know what happened. The rest of you will probably remain confused for at least 10 more minutes, but I promise by the end of the presentation, what happened behind the scenes here will become clear. And that's a very basic scenario of session puzzling. We can use the same scenario to do numerous additional attacks against the application. So let's go over again about what happened so we'll be able to really clarify what happened behind the scenes. Initially, we tried to access an internal page in the application without logging in. the application authentication verification mechanism checked our session memory, saw that it was empty, there wasn't any identifier within it, and kicked us out. So what we did was to go to another process that happened to deal with the same identity field, user ID, email, username, whatever it is that the application verification mechanism checks for. We activated that process, which happened to populate our session memory with the necessary value. After populating the session memory with the value through another process, which isn't the login, then we try to access the internal page again. The authentication verification mechanism checked our session memory and saw that now the session memory was not empty. It contained a username value, and therefore the user may be authenticated, which caused us to be exposed to this information, which we weren't supposed to see. That's the generic idea behind session puzzling. Usually when we attack an application, we attack it directly. When we send an SQL injection payload, we send it directly to the target page. In session puzzling, the concept is a bit different. We compose whatever attack payload we want in the back end, in the session memory, in the database content. We compose more and more and more pieces of the puzzle, and when that collection of values we need for the purposes of the attack is built in the server side, only then do we access the actual target entry point. Okay? So we can do a number of things with session puzzling, actually an infinite amount of attacks, but I'm going to focus around a couple of archetypes. We can use session puzzling to bypass authentication mechanism, to impersonate other users, to elevate our privileges, and even to perform traditional attacks such as SQL injection, cross-site scripting, gallop injection, and any attack you can imagine to the back end, to seemingly non-vulnerable locations that don't even receive direct input. And we're going to learn how to do that in this presentation. Now, just to clarify, what do I mean by traditional attack method? Traditional attacks, or what we currently do in most of our penetration tests, is to access a target page and attack it directly using inputs, access sequences, or whatever. While in session puzzling, we do something a bit more subtle. We access other entry points that populate session memory values or database values, which we will need for the purposes of the attack, and only then access the target page. A couple of real-life incidents that occurred with session puzzling, just to know what the magnitude of damage that can be caused through this attack. The first instance we had of that attack was in 2008. We had an insurance company hacked by a 15-year-old kid. You thought he was all sophisticated and stuff. However, we performed the forensics assessment on the application to see what really happened, and we found out something really bizarre. All the kid did was to use Paros. It was 2008 there, and we didn't have any good version yet. And he crawled the application twice. That's all. That's the seemingly miraculous attack sequence. The first time he called the application, something happened to the session memory associated to his account. The second time he called the application, somehow he gained access to the admin interface and defaced the entire insurance company account, website. So while investigating further, we found something very interesting. We found that the application had an administrative interface that verified the content of the user's session memory in the server side. And it checked whether or not that content contains identifying information. If it didn't contain anything, a login page would have been presented. If it contained anything whatsoever, it would have presented the links of the administrative application instead. So it just happens that the developers that wrote that application used the same template page for the administrative login page and for the contact us form. A simple development error. They used the same template page. So whenever somebody activated the contact us form, it populated the session memory with the values necessary to log into the administrative account. So just crawling the application twice with Paros enabled that kid to bypass an authentication mechanism of an application that was tested dozens of times. Okay? Additional, more interesting instances revolve around Oracle ERP e-business suite. For those of you not familiar with this application, which is still, by the way, vulnerable, it's almost as common as SAP. It manages ERP of many, many organizations.
And it has an interesting administrative account. I'm going to show it in a second, okay? And there's a page in this administrative account called oahtml.jsp, just to verify. It's not an HTML page. And it has a flow. It's an internal page that you can access without going through the authentication process, which populates your session with values that you can use to access the admin interface in that same application and gain control over the admin account. Now, that's how it looks like. It's just you access an internal URL in the Oracle ERP application, OA.html. I hope you guys can see something. And from there on, you can actually access the admin application as a guest. And from there on, you can use additional vulnerabilities to gain control over the administrative account, which the application, of course, is vulnerable to. So till this day, to my best knowledge, Oracle ERP as of version 11 and below is vulnerable. In version 12, they didn't even fix the flaws. They simply removed the interface entirely. So any one of you that ever gets to an Oracle ERP page that is like version 11 or below, you can actually use that same flow. Something more recent happened to Sony's account service system. A similar session puzzling flow that we're going to demonstrate later on enabled attackers to reset the password of any user they wanted to by using session values from other locations to verify to the password recovery mechanism that they have already answered the password recovery questions. As simple as that. Now, I can describe additional scenarios. It's not as common as SQL injection, but it does happen from time to time. But in order for you to understand the different varieties of attacks I'm going to explain in this presentation, I need to describe the session mechanism, or this a typical session mechanism first. So just so we all have some common background, how many people in the audience have technical experience in hacking or like pen testing or whatever you want to call it? Raise your hand. Oh, I'm in luck. That's good. So I won't have to explain too much about the session, which is good. So for those of you who aren't familiar with the session mechanism, I'm going to describe a typical web session mechanism. In a typical web session mechanism, the initial access from a browser to a domain is a non-authenticated access, and there's no identifying information. The initial access causes the web server to trigger the generation of a new session ID, a new ID card that the server provides to the user in a response, usually in a set cookie, a header, okay? The browser of the user stores the session identifier in a domain-specific cookie, and from then on, that cookie, that ID, is sent to the server in any subsequent request that the user uses to access the same domain. Now that ID, that identifier, temporary identifier that the user receives is associated to a server-side memory allocation, which is empty at first. But the server can place anything within. The user's favorite color, the user identity, or anything he wants to do. So initially there's nothing inside, but when the user eventually authenticates, the server usually stores in the session memory associated to the session ID various attributes, such as user ID, username, email, or whatever it is that the server relies on for various security checks. Now, the way it looks like, just to clarify, first access to the server returns to the user a valid newly generated session identifier. Any subsequent access to the server, the user sends that identifier within the content of the cookie over and over and over and over. It does not allow the user to affect any session values directly whatsoever, but it enables the server to take that key and check for that user what does he have in the session memory associated to that identifier. Imagine you going to a bank, providing the bank clerk with your ID card, and the clerk checking the computer what is associated to that identifier. It's pretty much the same with the session. And that's exactly what we rely on in session puzzling. Since the session mechanisms can contain many different attributes, such as user identifier, permissions, flags, inputs, and so on, many security mechanisms rely on the content in the session to verify different things, our identity, our permissions, whatever. And furthermore, many SQL queries, many data recovery or presenting features rely on the values in the session to filter results, to adjust the content for the specific user. So overriding those values or populating them or messing around with them in any way allows us to actually attack those authentication, authorization, security mechanisms from the back end, or at the very least, deliver our payloads to internal queries through a location that they usually don't verify. Now, there's a couple of archetypes that we can use in session puzzling. But first, let's discuss the mindset. As a pen tester, I'm getting to an application. Usually, my mindset is to send malicious payload through every parameter that seems interesting. In session puzzling, it's a bit different. It's a bit more logical. I have to ask myself a couple of questions. A, I'm currently accessing a page. Which security mechanisms are active in that page? The answers may be numerous. Authentication, verification, authorization verification, CSRF verification, and so on and so on and so on. After identifying or at least predicting which security mechanisms exist within the target page, I have to understand which session values they may rely on, such as username, permission sets, and so on. After doing that, understanding which security mechanisms exist in the page and which session values they rely on, I want to deal with the content of the page. If the page presents content, and we're going to use the same idea later on, I want to understand whether or not it's filtered to something in the session, or whether or not something in the session actually is used to manipulate that content. And finally, after understanding which session attributes are used for the purposes of filtering results and for the purposes of verifying a couple of things in security, I want to do additional things, which is generally to find other entry points in the application that may use the same content, that may use the same type of information, so I can use them to populate the session, or at least override some values. So let's look at a couple of examples. I want to try that mindset with you guys to see if you picked it up, okay? So I have an internal page in the application. I'll just log out, log in again. User 1. Take a look at the following statement. Can you see the following statement? It tells me, as an authenticated user, hey man, you've bought 397 puzzles so far. In order to present that information, the server probably should have accessed the database or some sort of data repository and filtered the result. Okay? Any idea what is the value used to filter those results? Anyone whatsoever? Which values should be used? Username, user ID, or anything specific to the user identity, right? So this page does not receive any input whatsoever. However, it still presents content that is filtered by results, which means it's using probably the session mechanism and attributes within it. So if this mechanism uses the username parameter in the session, other locations which use the same value can be used to deliver malicious payload to that page. So I can access other entry points, such as the registration page, which, again, in most applications, allows me to define some sort of username. And since it's a multi-phase process, it has to store that value somehow until the completion of the process. So I'll simply send a quote or some value in the username, which may cause an SQL exception. Now, seemingly nothing happened because that was not my target, and this is not vulnerable to SQL injection. But accessing other pages which use those session attributes right now will enable us to deliver malicious SQL payloads to a seemingly invulnerable location. In most scenarios, WAFs won't even identify that. I'm not talking about logical scenarios such as delivering or overriding identity values, something a WAF won't even comprehend. Even in simple version, in the most simple version, just delivering those payloads to a page that is not even interacting with the user, this not in a visible manner will enable me to bypass many security mechanisms, okay? So that's just one example. It's a typical archetype of delivering malicious payloads to an application to a seemingly vulnerable location. It can be used for LDAP injection, SQL injection, anything you want, name it. Any attack you want can be delivered in that manner. Now, since most automated scanners don't check a fragment of these vectors, there's, in my opinion, numerous applications which are still vulnerable to them. Since pen testers don't have, until that presentation, I'm going to talk about my proposal later on, any automated tools to verify those different sequences, which are very complicated if you think about it. There can be 100 pages in the application and 20 million different sequences that you can try to get to the correct result, okay? So those bugs may be out there. Other scenarios, let's go to the scenario that was done on Sony, okay? Let's say we have a password recovery mechanism. I'll just initialize the session so we'll have a blank start, okay? Let's say we have a password recovery scenario, and I'm a low privileged user, user 1. I know my own password, but I want to see how the process is constructed, okay? So I'll start the password recovery mechanism. I'll send user 1. I have my own recovery question, which is what is the magic word, which in my case is now, okay? And eventually I'll get to the end of the process. Now the final URL at the end of the process is recovery success. That's the final URL. Now there's a couple of attacks that can be used to bypass password recovery scenarios. One of them is forced browsing. Some of you probably, or forceful browsing, or whatever you want to call it, okay? Let's try that attack. Let's try to recover the admin password. Let's say I'm not a Hitchhiker Guide to Galaxy fan, and I don't know what the ultimate answer to the ultimate question of life, the universe, and everything is. So I can't recover the admin password. And I'm trying to use a forced access, a flow bypass attack to get to the final phase, to see the admin password. In this scenario, the developer isn't that dumb. He performs flag validations for every phase. Phase 2 places a flag called phase 2 that phase 3 verifies. Phase 3 places a flag called phase 3 that phase 4 verifies, and so on and so on. So when I'm trying to skip phases, he identifies the scenario and kicks me out, okay? But I can do something else. Let's say an application has a couple of multi-phase processes, all of them enforced, some of them simpler than others. In our application, there's a password recovery mechanism, and there's a registration mechanism, both of them multi-phase processes. I can use flags generated by one process to override flags of another process. Let's see it in action. Something very similar happened in Sony, okay? So I'm going to start a registration process. With some bizarre username. It doesn't really matter because I don't need the username. I only need to override or populate my session with the proper state flags, okay? I've currently started phase 1 of the registration process, but the value in the session memory, which is the username, is currently BBBBBB, which isn't the user I'm interested in. I'm going to override that value to another process, just so the username in the session will be something I am interested in. I'll go to the password recovery mechanism and start it with the word admin, okay? Since the password recovery mechanism stores that value in the session, it will override the value which is currently in the session, okay? Which was BBBBBB, but the state flag, flag 2, still exists. I'll go to the registration mechanism and continue to the third phase. I'll enter my phone or whatever other information required by the process, and eventually complete phase 2 and get the phase 3 flag in my session identifier. Now, notice, I got to phase 3 in the registration process, but in the password recovery process, I'm still stuck on phases 2 and 3 because they get and verify my answer, which I don't know. But since my values, my state value, flag 1, flag 2, flag 3, or whatever they're called, have been populated by the other process, I can now try and access the final URL in this process and see the admin password. Since the flow restriction mechanisms verify the existence of certain flags in the session, I can now see as the mechanism that there is a flag 3 in the session because as an attacker, I've done the other process to populate those values. Okay? Same idea for various other attacks. Simpler scenarios, okay? By the way, are there any questions so far regarding the attack, those scenarios that I've demonstrated, anything whatsoever? Yes?
Would it work to perform the password reset feature almost until the bottom to show the password and then start a new session just entering the admin password?
Could you repeat the question?
Sure. He asked whether or not it will work if I will start the entire process and then change the admin username and password. That's what it depends whether or not the developer is deleting stuff from the session. Theoretically, yes. Any scenario, there's no one formula. It depends which development mistakes the developer does, how it works with the session flags, and there's various different bizarre behaviors. In one occasion, one of our employees, a fantastically brilliant guy called Oren Hafif, he managed to get a password to his phone by initiating the password recovery mechanism and then registering another phone number. It turns out that the server somehow got the phone number from the database, stored it in the session, and used the value in the session to send the password to. So just by registering and overriding that value, he was able to get the password of another user to his phone. There's numerous vectors you can use in that scenario. There's not really one archetype. Did I answer the question? Any other questions so far? Okay, one last sample, and we'll get to a bit more complicated scenarios, okay? One more simple sample of session puzzling. Now, as I mentioned earlier, it's a pretty strong vector as far as authentication is involved, since in most scenarios, a WAF or anything that works on signatures won't identify a normal process as an attack. So just accessing the application as a simple user, even if there's no flow in the user authentication validation mechanism, just accessing the application with a valid username and then finding any feature that may override that username will enable us to impersonate other users. In this case, admin, but it can be used for any other user, or to elevate our privileges. As simple as that. We log in, and then we find some location that messes around with identity information, override the session value through it, and then access the content. Now, as you can see, it can be really powerful if you use the proper mindset and analyze each page, watch mechanisms working within the context of the page, which queries are using content from the session or database values to filter stuff, and so on and so on. But in a large-scale application, hundreds of pages, that's a really tough task, which is why we invented a tool called Diviner, okay? I'm going to skip a couple of phases. So there's numerous sequences in session puzzling. Actually, the first instance we ever came upon was a 7-sequence attack. It was a code of a bank in Poland, and we had to access 7 pages, one after the other. Each page populated something in the session that the other page required. So it can be insanely complex sequences, and there's numerous possibilities with authentication, without authentication, with CSRF token, without CSRF token. So what we did was to create an application, an extension to the famous ZAP proxy project, which tries to verify the effect of various entry points in the application on other entry points. Just a clarification, this project is called Diviner. It's hosted in Google Code. Let me just, that's the website. You can't find it by writing Diviner in Google. You will never find it. You will find some shitty TV series which aren't worth your time. So you have to write diviner hactics or diviner Google code, whatever of those. Any one of those will get you there. You have to download ZAP version 2.1. It doesn't work on the latest version yet. We're working on it. They released a recent update that messed around a couple of things. So in order to do that, you'll have to actually select all downloads in ZAP proxy website. Download version 2.1, and you'll be able to install that extension. Now, the way that extension works, it takes every page in ZAP's history, every page whatsoever. It allows you to decide which pages and payloads you want to use, and it checks every possible scenario of access and the behavior of the application in response to that scenario. It will go to page 1 with the history input and access page 3. Go to page 1 and access page 4. Go to page 1 and access page 7. And then do that again with authentication, without authentication, with CSRF flags, while replacing the session values, while replacing the parameter values, and so on and so on and so on. It will eventually get a large list of behaviors, okay? A very large list of behaviors. Behavior 1, behavior 2, behavior 3, which it will use a couple of logic requirements. I'm not going to explain that, don't worry. It's just for the background, okay? So it will use various scenarios to get as many behaviors as it can get. Eventually, after getting all those behaviors, it will interpret those behaviors into the following map, which shows how each parameter in each entry point affect the entire application. For example, the password recovery mechanism is a recovery mechanism, where is it? The resolution kind of screwed things up. Is this parameter in the second page, received by the second page of the password recovery mechanism. Just by clicking it, I can see immediately that that value is presented in the output of the view profile page. Meaning it's received in one page, but it's presented in the output of the view profile page. There's a reflection, potential reflection of cross-site scripting attack, okay? It's based on the session, not on the database. It will identify whether or not it's persistent or not. You'll actually see that it's stored in the database or it's stored in the session. And furthermore, it changes the content of the page in 28%, which may or may not refer to the fact that it's used to filter results in the database. So we'll be able to see how each parameter in each section of the application affects the rest of the application. Furthermore, we'll be able to see whether or not it requires authentication, whether or not it requires CSRF tokens or any other attributes in order to reconstruct the exact same scenario. Just to see how it works, let's see. Let's say that we have a username parameter, and we see that it affects the output of the view profile page, and I'm currently logged in and accessing the view profile page. I'll be able to execute different attacks using the same page. And just to show you another scenario, you'll see that it also affects the main menu page. I don't think I accessed it, so I may not be able to see it here. So if I would have crawled the main menu page, you'll see that it also affects the output of the main menu page. It's presented back. I can verify that manually. I can simply see that my username is presented here. So that scenario can enable me as pen tester to identify an indirect cross-site scripting attack with two URLs. One URL is in the entry point, one URL is the target. So I'll be able to access that page and then override the relevant value with a script or whatever I want to override it with. I'm sorry for the cheesy alert XSS stuff, okay? Actually, I think the registration mechanism is probably better for that scenario, since the username doesn't have to be valid, not really. And voila, an indirect cross-site scripting attack. So I can use that interface to see how each page affects every component in the application. The output-input exception values
can be used, exception by the way, you remember the indirect SQL injection attack? It replaces the different values with quotes or LDAP characters or whatever you guys choose in the wizard, which I'm going to demonstrate in a second. It actually tells you there's a session-based exception in response to that value, okay? Or there's a database-based exception in response to that value, or there's a file, whichever repository it identifies. Furthermore, I won't be able to explain the whole process right now. You guys can see presentations about Diviner online. There's a number of those, at least 4 that I remember. It also enables you to see why it happens, because it converts the behavior into a pseudocode representation, okay? So it may not make sense right now, so try and bear with me for like a couple of seconds. The fact that the page behaved in a certain manner is one conclusion, but there's a secondary conclusion, the elusive obvious, which is that the line of code actually exists. It may or may not make sense to you, but if there's a behavior, the behavior is generated by some sort of line of code. The existence of the behavior means that a specific line of code exists. We can present that line of code. So it will enable us as penetration testers to identify those indirect scenarios, understand why they occur, which page affects what, and exploit it to uncover vulnerabilities that nobody else uncovers, which can bypass to us, which can abuse security mechanisms to attack the application, and so on and so on and so on and so on. Any questions so far? So I don't have much more time. I initially planned to show you how to use temporary session values that only live in the session memory for milliseconds, using other attacks for the same purposes. But you guys can read all about it. Just Google session race conditions. It's generally session puzzling with race conditions and timed attacks designed to do the same things. So whenever a developer makes a single mistake, even for a millisecond of populating an unnecessary session value, we can exploit it to bypass many, many security mechanisms and deliver our attacks in many different ways. Finally, some risk mitigation. We all figured out that session values or database values or any server-side trusted resources are rarely validated by developers. So that means that developers have to behave differently when they use those session attributes. Now, you won't find those recommendations in OAuth, which means that most applications these days don't have those risk mitigation factors I'm going to describe, and they should in order to prevent those scenarios, okay? First of all, as a general recommendation, avoid populating or using the session memory for anything that's not really necessary. Furthermore, never use the same session attribute for different mechanisms in the application. Don't use the attribute username for the password recovery and registration and username or whatever. And that one is common. That one's common. You haven't heard about it because the pen tester has to come with a different mindset to the assessment to find the specific vulnerabilities. But once people will start testing that, there will be numerous vectors, okay, that will be published. At least that's my opinion. At least that's what I'm seeing in Hacktix, because there I can actually force the testers to do that. That's the authority of the CTO, okay? So finally, as a very effective recommendation, my recommendation is to use, instead of storing simple attributes, strings, numbers, so on, store or use the session memory to store only classes with the name of the process you're using, like the login class or the password recovery class, and each class will have its own attribute. That will mitigate many of the typical behaviors that developers may use to generate such flows, okay? Other than that, if you guys are searching for additional resources, okay, by the way, Diviner, I haven't showed you. It can be activated through Zap's menu. There's like Tools, Launch Diviner. That's all. Tools, Launch Diviner. It's a simple next installer. It works without any specific configuration. Just use Zap version 2.1. It has a fantastic wizard that allows you to choose the domain, which is the target domain, which plugins you want to use, which exceptions should be notified in the GUI, which payload should be used to generate exceptions, to generate reflections, which URLs you want to test. whether or not you want to replay all the history before a page, between a page to the target page, and so on and so on. Various flow or sequence restrictions you want to do, with login, without login, or whatever. Which URLs you want to test, and so on and so on and so on and so on. It's all inside. You can all use it without too much effort, okay? Finally, some additional resources about session puzzling. Those of you who want to read more, there's a white paper published in 2011, to my best knowledge. Only 2,000 information security consultants in the entire world are aware of it. Probably, I think there may be other instructors presented that subject later on, but the exposure to the subject is very, very limited. Hence, the amount of published vulnerability is relatively low. Also, there's a YouTube channel of Hactics. It's generally how Hactics see in YouTube or whatever, we'll get to it, which presents additional sequences we uncover and publish, or additional sequences you can learn from. There's a couple of other presentations that other instructors presented over the years. You can see them by downloading the presentation from the website, and that's pretty much it. Any questions? Go on. Well, hope you enjoyed, guys, and enjoy the rest of the conference.
So, no questions at all? Ah, back.
Oh. Yes.
Yeah, question about the cross-site scripting attack you showed. To me, it doesn't seem exploitable. Can you run this against other users, or is this only working against your own session?
Of course, of course. It's a two-phase cross-site scripting. Usually in a reflected cross-site scripting scenario, you refer the user or convince him to click a single URL. However, if like a user is using Facebook and your application is online, you can refer him to two URLs. You refer him first to the entry point, which populates the session value, and then you refer him to another one. If you change the source of an image twice, in like a difference of 1 second, it will work. Or even if you're convincing the user to click a URL, you don't have to access the real website directly. You can access your website in the URL. You convince the user to access your website and then refer him to one URL at a time, using iframes, image sources, or whatever technique you want to. You can use a 7-sequence session puzzling on the user. It doesn't really matter. You won't be aware of it. Okay? Any other questions? Yes.
Any plans to implement the plugin in something usable like Burp Suite?
You don't need to shout that for Simon. Okay? So. This project costed us about 1,500 hours of development. So converting it to Burp in our current resources seems like an insane job. So for now, I can only commit to improving it upon Zap. I'm sorry. It has nothing to do. I'm a fan of Burp as well. I purchase licenses for all my consultants. And we use Zap as well, but the effort is just insane. We are, however, adding additional features to that as we speak. I admit this is currently slow. The amount of requests that the tool is using is growing exponentially. I actually don't recommend using it on more than 30 URLs at a time. But we're currently working with a couple of universities which we managed to somehow convince to send students to help us in the development of this project. So we're currently working on making it more multi-threaded, or support multi-threading better, and in addition to that, convert additional behaviors to other lines of code. So we'll be able to see how a page behaves just by using Divine on it. Okay? Sorry, that answer sucked. So, any other questions? Okay, guys, enjoy the rest of the conference.
Thanks.